Welcome back to the MPLS lab training. We're going to go ahead and pick up where we left off from the last video, and we're going to go ahead and build the customer networks now for the MPLS backbone. So we'll still be working on PE1 and PE2. However, this time we're going to go ahead and we'll be building up the customer configurations to be able to talk with the customers, to be able to peer with them and communicate with them. So in our previous video, we set up MPLS across the backbone between PE1 and PE2, and we set up LDP. So at this point, we have a fully functional MPLS backbone, and we are ready to build the customer networks. So we're going to go ahead and start out with VRFs. We'll build VRFs on PE1 and PE2. VRF is just simply a virtual routing and forwarding instance. It's where we put the addresses and so forth, and how we separate out the routes from the global routing table and putting them into their own customer networks. And then what we're going to go ahead and do is we'll build up IP addresses on the interfaces, and then we'll also set up routing to the customer. So we're going to do this for customer 1 site 1, customer 1 site 2, and we'll also do this for customer 2 site 1 and customer 2 site 2. So let's go ahead and go to the command line. We'll start working here on PE1. And the first thing we're going to do is we're going to build a VRF for customer 1. Okay, we're going to use a capital C1, and it is important because this is case sensitive. So if we were to put a small c in there, it would think of it as a small c. So we need to make sure that we get the case right. So again, the VRF is just a virtual routing and forwarding instance. By default, all interfaces on a router are in a global VRF. That's just a default routing table. By creating a new VRF, say for customer 1, what that allows us to do is have a whole new routing process, like a mini router, if you will, within this physical router to be able to put all the customer routes. So we'll need one for customer 1 and customer 2. So let's go ahead and start off here and keep building customer 1's VRF. Give it a description. We're going to go ahead and give it a route distinguisher. So the route distinguisher here, the value is going to be 100:1. What the route distinguisher does is that's what gives the uniqueness to the route. That's how the router itself can differentiate between the global table or another routing table, say another VRF. And that's actually what allows routes to overlap. So say for example, between customer 1 and customer 2, they use the same IP space. That would be acceptable. There wouldn't be any conflict because those routes are in different VRFs, and it's the route distinguisher that gives it its uniqueness. So now we're going to go ahead and set route targets. Both export and import. What the route targets do, the route targets are BGP extended communities. That's what they get used for, and that's how we bring routes in and out across the MPLS backbone. So for example, when we export routes through BGP, VPN, v4, which is what we set up in the last video, and with the extended community, we'll tag that with 100:1. And that means other routers that want to import 100:1, they'll do so, and they'll get routes from this routing instance. And then we'll also go ahead and import. So if somebody else is exporting routes as 100:1, this router will go ahead and import them. Now, one other thing we could have done here is we could have just done route target both 100:1. Now that would have done the same import and export command in one. I show you this, but I wanted to break it out so you saw the import and export. The final thing we need to do here is set it up for an address family IPv4. Okay, and that's all we have to do there. So let's go ahead and look at this. So here's our configuration right here. We got our VRF. It's got its name and the description, a route distinguisher, and the route targets, and then it's set up for address family IPv4. So let's go ahead and now we'll build the second one for customer number 2. Okay, so now we've got it set up. So this time I use the route target both commands. So let's go ahead and look at that config. and you'll see it put, like I said, the import and export in there. So now we've got both the VRFs built. Let's go ahead and save our changes here. So now we've actually built two virtual routing and forwarding instances, one for customer 1, one for customer 2. So let's go ahead and look at our diagram one more time. At this point, PE1 has VRFs for customer 1 and for customer 2. Our next step is going to be to associate the interface gig01 with customer 1's VRF, and then on the other side we're going to go ahead and put in gig02 and a customer VRF number 2, and then assign the addressing. So let's go back to the command line and do that. You can see gig01 is just default, and gig02 is the same thing. Set a description. Okay, so we're going to go ahead and set the IP address. Now I'm going to show you something here, and basically right now this interface gig01, it's a part of the global routing table, the default routing table on the router when it comes out of the box. So if we put in the IP address, if we put that on there like that right now, that IP address is a part of the global routing table. So we need to associate this interface with the VRF. We do that with this next command. Okay, so you'll see we got an error message here. It says interface gigabit 01 IPv4 disabled and address is removed due to enabling VRFC1. And we can see that it did remove the IP address. And the reason for that is because, like I said, the IP address was a part of the global routing table. When we associated the routing table with VRFC1, it took out all of the default global table information in there, and then it reset it now. So we need to go ahead and put that IP address back in. So the right way to do it, the right order of operations, is to go ahead and associate the interface with the VRF and then put the IP address in, which we'll do on the next one. So we'll turn on no IP redirects, and we'll turn off IP redirects, and we'll turn off proxy ARP. And take a look at the interface again. And there we go. That interface is set, ready for customer 1. Okay, and you see this time it didn't strip off our IP address because we did the order of operations the correct way. Okay, and we can see now that the configuration is all set for gig02, so customer 2's interface is also ready on PE1. Okay, so let's go back to the diagram. So if we look at what we've done now, we've gone ahead and set up the VRF interface and the IP address here for gig01. We've also done the same thing here for gig02. We assigned it the IP address, the 192.168.0.0/30, and .1 is on this side. And then we did the same work on the corresponding side, 192.168.1.0/30 and .1 on gig02. So at this point, we're going to go ahead and set up on PE1 the routing. We'll prepare the routing for an eBGP session. You'll see that we're going to be eBGP over to customer 1. So as we know, we set up BGP on PE1 before through the VPN-v4 address family. This time we'll be setting up an IPv4 address family, and we're going to do that in the VRF for C1 and C2. And we'll be appearing here, you'll see remote ASN is 65,000 for CE1A, and it's 65535 for the ASN for CE2A. So let's go ahead and go to the command line again, and let's work on that. So we'll start off by looking at our BGP routing. And you can see here we've got our routing instance, and this is the configuration we've done in the previous video to set up VPN v4. So what we want to do now is we want to go ahead and create the additional address families under here for C1 and C2. To do that, we go into the routing process 64512 and we type in address family IPv4 VRF C1. Now that puts us into a new address family, and that's going to be specific for customer 1. So let's go ahead and set up the configuration here. So we'll set its remote AS, set the peer to be 65,000. We're going to peer directly with the IP address on the other side of the interface. We'll set up a description. We'll set up a password to authenticate the adjacency. And then we'll adjust the timers. We'll set it to 5-second hellos and a 20-second hold timer. We'll send a standard community. We'll allow that to be sent. We'll go ahead and activate it. And one last thing that we're going to do here is we're just going to go ahead and advertise the transport network. We could do that on the other side, and we will, but we'll go ahead and do it on this side also. Okay, and that's what we've got now. So let's take a look at that again. And you'll see now that we've got VRF-C1 already set up. So we need to do the same thing for C2. So again, we're just going to go into the address family IPv4 VRF-C2 now. And again, it is case sensitive, so make sure you put in the capital C. Set a description. Set the password. That's also case sensitive, obviously. Set the timers. Again, 5 and 20, 5 seconds hello, 20-second hold timer. Send the community. Okay, and we're going to add in one additional command that's not present on the other side. So we're going to go ahead and put in the AS override command. And what the AS override command does is that allows the customer, let's go to the command, let's go back to the diagram real quick here. So what you'll notice here on customer 2 is both site 1 and site 2 have the same autonomous system number, 65535. So that is something that you can do with BGP. However, by default, a router, when he sees his own AS, in this case 65535, if he sees a route with its own AS in the route, then it's going to discard it. It won't use it because it's going to think there's a loop. However, this is something that's normally set up, and in fact, some providers actually require it. I think it was AT&T that did this Actually, I believe AT&T has unique, they allow the customer to have unique ones, but it was probably Verizon that we had to use the same one everywhere, and that was what we ended up having to do. So what they do is they put in the AS override, and essentially what that does is when customer, say customer 2, site 1 advertises a route over to PE1, PE1 will take that, send it to PE2, and then PE2 will actually take off the 65535 and apply 64512 in the routing update. And that's what the AS override does. It overrides the customer AS and it applies that so that customer 2 site 2 will accept that route. So that's what the AS override does. And so I did that specifically. I wanted to show you that there's different ways to set up the pairing with the customer. One is where the customer has all unique BGPA autonomous system numbers, and one's where they have them the same. And there's just this one additional thing you have to do if they're all the same. So let's go ahead and finish off our configuration here. Go ahead and activate it. And then we'll go ahead and set up the network statement so that we'll advertise the transport in. So let's take a look at that config. Okay, and there we go. We got C1 and C2. They're identical except for the AS override, and then obviously the password and description are slightly different here in the ASN. So the commands effectively are the same. Just remember the AS override command is needed if if the customer uses the same autonomous system numbers for BGP pairing. Let's go ahead and save our changes. That's it for here on this router. We're going to go to PE2 and we're going to do everything that we just did, and we're going to do it on PE2. And there's very limited testing we can do right now though, because obviously the customer side hasn't been configured at this point. So the next video we'll do that. We'll go ahead and work on the customer side and build up the addressing and everything there. So let's go ahead and go over to PE2 now. And we will go ahead and build the config on this side. Now you can obviously take the config that we put in on PE1, put it in Notepad, manipulate it, and put it back in. That's something you can do, or you can just get used to typing it by hand like I'm doing here, and it'll actually reinforce it a bit better if you do type it in by hand. Okay, so now what you can see is that we've got both of the VRFs done just like we did on the other one. Now this is identical to the other side, and we want it to be identical. So we want to make sure we're importing and exporting the routes. We could actually set the route distinguisher slightly different, and there's different reasons to do that, especially when we're load sharing traffic. In this case, we're not doing that. We're trying to keep it simple, and so we're just going to keep the route distinguisher the same. However, they are identical here, so that's what we want. So let's go back to the diagram. Now we're on PE2. Down here, we're going to go ahead and build the configuration on gig 01 for customer 1 and gig 02 for customer 2. And we look at the IP address for gig 01 is 192.168.0.4. That's a /30, and we're going to go ahead and put .5 as the interface IP. In customer 2, we have a very similar address. It's 192.168.1.4, and we're going to be .5 on the gig 02. So let's go ahead and configure that. set the description. Put it into VRFC1 through the VRF forwarding command. Okay, and there's gig01 configured. Put it in a VRFC2. And we'll assign the IP address. And there we go. So now gig 2 is also configured. At this point, our last step that we need to do is we need to configure BGP on PE2. So let's take a look at the diagram here. And we can see that for customer 1, that site has got an autonomous system number for eBGP session of 65001, and customer 2 has 65535. So let's go ahead and we'll build another adjacency for customer 1 and customer 2 off of PE2, and we're going to peer directly to the other side of the IP address. So one thing to note is by default eBGP peering is only one hop away. You can set it to be more. There's some things to know about that that you can read online through the Cisco website. However, by default it is one. So if you try to do it, say 2 hops away, it's not going to work. And we are only 1 hop away though, so that's what we're looking for, and that's typically how it's done when you're working with MPLS with a provider, or if you're doing your own as we are here. Let's look at our BGP routing config again. So we'll see it's just like it was on the other one we looked at it. We've got our BGP set up for VPN v4. That's all that's set up right now. We're going to go ahead and build in the IPv4 address families for customer 1 and customer 2. Okay, and the remote AS is 65001. We'll set the description. We'll set the password. We'll go ahead and set the timers again to 5 and 20. This doesn't have to be always consistent, say from customer 1 and customer 2, but it's a good idea to do it. Obviously this just relates to the adjacency, but it's good to be consistent. So we do want to make sure that we keep the same timers. So we'll send a standard community. And then remember this one here, actually this is not the one. So on the next one we'll need to do the AS override. So customer 1, let's go back here to the diagram. You see customer 1 does have a different ASN for site 1 and site 2. So it does not need the AS override, but we will need it for customer 2. So let's activate that. Okay, now we need to build the second BGP session for customer 2. So we'll go into VRF C2 under the BGP address family. Set the password. Then we'll go ahead and set the timers. Send the community. And set the AS override command that we were talking about. And we'll go ahead and activate it. And then we'll set the network statement to be able to advertise the network statement. Okay, so let's look at the BGP config on here. We'll see that C1 and C2 are built. Again, the main difference here, we got an AS override command on C2. So these are now ready. The MPLS provider backbone here is now configured the way we want it to be for customer 1 and customer 2 on both PE1 and PE2. In our next video, we'll go ahead and we will start configuring the customer site equipment.